What we're doing today is solving equations that contain multiple variables. This is part one. Part two is more application problems and things like that. And keep in mind, whenever we solve equations, we're using PEMDAS, please excuse my dear Aunt Sally, in reverse order. We use PEMDAS, going to the right. When we're simplifying algebraic expressions, when we're solving, we go from the right to the left. We actually go in reverse order. Right. So we have 5 examples here, and the dots represent what variable we're going to solve for. So we have PEMDAS in reverse. All right. So let's look at a equals b minus c. Do we have addition or subtraction here? Yeah, we do. We have a subtraction of a c. We want to get b by itself. So that means we want to have the leading coefficient be a positive 1, and we need to get rid of this negative c. So how do we get rid of a negative c? We're going to add it to both sides. Add c. A and c are unlike terms, so we're going to have a plus c is equal to b. And keep in mind, you can rewrite these. B is equal to a plus c. The second example, we want to get this c on one side and get rid of this b and this negative sign. The first thing we have to do is get rid of this b. It's a plus b. You always look at the sign in the front. It's a plus b, so we're going to subtract b from both sides. Subtract b. A minus b is equal to negative c. Now, we're not completely done yet because we still have this negative sign. Think of this as a negative 1c, a negative 1 times c. How do you get rid of a negative 1 times a c? You're going to divide by a negative 1. And divide this entire other side by a negative 1. If you have an a minus b divided by negative 1, it's the same thing as negative a plus b is equal to, these will reduce to a positive 1, and we're left with just c. In the third example here, we have m is equal to d times z. We're going to solve for just z. We have multiplication here. We undo multiplication through division. So we're going to divide by d, and if I do it over here, I must do it to the other side of the equal sign. And now we have m divided by d is equal to z. In example number 4, we have k is equal to g minus fm. You have to think of f times m as one thing. So we're taking g and we're subtracting this one thing, the product of f and m. So if we want to take g minus something, if we're subtracting it, how do you get rid of it? If you're solving, you're going to add it to both sides. So we're going to add an fm to both sides. All right, so now we have k plus fm is equal to g, and we're done. All right. And in this last example, we want to solve for m, so we need to get rid of this g, this minus sign, negative, and this f. All right. The first thing we're going to do is, this is connected through addition and subtraction, the g with this thing, the fm. So we're going to subtract the g because it's a positive. Subtract the g, subtract the g. We have k minus g is equal to negative fm. All right. Now we have to get rid of the f and the negative sign. All right. If you want to, you could think of this as negative 1 times fm. We'll divide by a negative f. All right. And negative f divided by negative f is just 1. Anything divided by itself is 1. And we're going to do the same thing over here. Right. These will reduce to just a 1. And we have k minus g divided by negative f is equal to m. All right. We'll finish up with these 2 examples, solving for x in the first problem and a in the second problem. If we want to solve for x, it means we have to get rid of this a value and this negative ay. And there's a couple ways you can do that. I would suggest do what you know or do what you used to. Let's add an ay to both sides. Add an ay. So we have z plus ay is equal to ax. Now we want to get x by itself, so we have to get rid of this a. That's multiplication. We're going to divide. Divide it over here and divide it on the entire other side. Those are gone. And now we have z plus ay over a is equal to x. Now this can be reduced a little further because you have an a up here and an a up here. And what you want to do is think about when you add fractions together. If you have common denominators, you can put the numerators together and keep that common denominator. For that same reason, we can actually pull them apart. So we can actually rewrite this as z over a plus ay over a is equal to x. Now think about it. If you were to add these back together, you'd have what we started with. Z cannot be divided by a, so that's going to stay the same. But these a's will reduce, and we're left with just a y is equal to x. Right. This last problem is probably the trickiest because You want to solve for a, so you might say, okay, let's add an ay to both sides. But then you have a's on both sides, and you really want to, when you solve equations, you want to keep your variable you're solving for, keep them on one side. So what I would suggest here is we can actually rewrite this as z is equal to a times x minus y. All right? And if you're not sure about what I just did right there, use the distributive property and distribute this to this a to both of these terms on the inside, and you actually get back to where we started. If you see an a in both sides, you can actually factor it out, and you're left with just an x minus a y. So now we have a times the quantity x minus y, right? And this is multiplication here. To undo multiplication, this is an entire thing through parentheses. It's one term, think of it. If we want to get rid of an a times an x minus y, we're going to divide by an x minus y. If we do it over here, we're going to do it over here. All right. Those are gone, and we're left with just z over x minus y is equal to a.